insights and discussions from our first day together. We explored how artificial intelligence is transforming agriculture from multiple perspectives. We began with sensing and data intelligence, examining how observations from sensors, satellites, and digital platforms allow us to better understand agricultural systems. We then discussed how these data can be transformed into services and operational tools, enabling smarter and more efficient farm management. And finally, we reflected on the innovation, systems, and socioeconomic dimensions that shape the adoption of these technologies, including governance, policy, ethics, and the broader impact of digital transformation. Across all these discussions, one idea has remained clear. Artificial intelligence becomes truly meaningful when it supports natural intelligence, the knowledge embedded in farmers, ecosystems, and agricultural communities. Today, we continue this journey by looking further along the agri-food value chain, from the field to food systems and industrial processes. I would like to introduce the moderator of this session, María José de la Haba, Associate Professor at the University of Córdoba in the Department of Food Science and Technology. Her research focuses on the application of advanced sensing technologies and analytical methods to improve quality control and efficiency in agri-food production systems. She has worked extensively on non-destructive sensing techniques, such as near-infrared spectroscopy, for the monitoring and characterization of food products and processes. Her work also explores how digital technologies, sensors, and data analysis tools can support smarter and more sustainable food production systems. This expertise connects closely with the theme of this session, which examines how Industry 4.0 technologies and artificial intelligence are transforming food processing, reducing waste, and supporting more circular food systems. Please join me in welcoming Professor María José de la Haba, who will moderate Plenary Session 4, Industry 4.0 and Sustainable Food Systems.
Good morning, everyone. Thank you very much for that kind introduction, Aitana, and thank you, Rosa, for the invitation to attend this session. It is a pleasure for me to be part of AI-AGRIFOOD 2026 and to contribute to this important discussion. I would also like to thank the organizer for bringing together such a diverse and inspiring group of researchers and professionals. The topics we are addressing not only today, but these 2 days, are not only scientifically exciting, but also critical for the future of our agri-food systems. As we move forward on the second day of the conference, this session offers a valuable opportunity to explore how Industry 4.0 and 5.0 and artificial intelligence are reshaping food processing, enhancing efficiency, and advancing sustainability across the value chain. I'm very much looking forward to the insightful presentation and the discussion that will follow. Thank you all for being here. Before we begin, I'd like to briefly explain how the session will be structured. We've organized the session into different parts. In the first one, we'll have 2 keynote talks focused on artificial intelligence in food processing, waste reducing, and circularity, followed by a discussion where you will have the chance to ask questions. I hope you do. In the second part, we'll move on to the 3 short oral communications, and afterwards, we'll open the floor again for further discussion with the speakers. Having said that, we are fortunate to have 2 excellent speakers joining us, both recognized for their expertise and contribution in their respective fields. I'm sure their presentation will inspire interesting discussion. It is my pleasure to welcome Professor Pérez Marín and Dr. Hassoun. Please come here and take a seat. Please. Our first speaker, Dr. Lola Pérez Marín, who is full professor at the HCIAN of the University of Córdoba, with extensive experience in non-destructive near-infrared spectral sensors and multivariate data analysis with application across a wide range of agri-food fields. She has contributed significantly to advancing knowledge and innovation in this area. She's currently the president of the International Council for Near-Infrared Spectroscopy, which reflects her leadership and international recognition in this field. Today, she will share her insights on the new era of NIR sensors to transform the agri-food sector. What do you want?
Okay, thank you very much for the introduction. I'm going to have to, okay. Yes. Buenos días a todos. Good morning, everybody. It's a pleasure for me to be here. I would like to thank the organizers for their kind invitation to be here, but also I would like to express my special feeling to be here in the building that was the house of our faculty during many, many years, and I study here my degree, so it's a pleasure to come here again. I'm going to talk about NIR sensor and how this new era, this new status of the NIR sensor can transform the agri-food industry. I'm going to show how we are moving from just to have data to provide intelligent decision.
You have to point there.
Now, it's perfect. First, I would like to introduce you which are the current industrial demands in the agri-food sector. It's clear that the industry has to face to issues related to product quality, product authenticity, and fraud detection. Also, process control to get the production to be more efficient in the production. But also, it's clear that they need to have tools for real-time decision making, and of course, all of this in a frame in which the digitalization is a must. I don't know. Maybe it doesn't work very well. No. Another important thing nowadays is that the food supply chains are becoming more and more complex every day. So because of that, we need to control all the whole supply chain from the farm to the fork, I mean with the primary sector to the consumer. So to do this, it is clear that the traditional analytical methods are not enough. So we need to innovate in the control, and in this case, there are many types of sensors that could provide a solution. This alternative, we have NIR. Why NIR is interesting? Near-infrared sensors are interesting because all these characteristics that you can read in the slide. It's a digital signal. They are very fast, precise, easy to use in routine, non-contaminant, but mainly because it's a non-destructive technology, and we can implement this technology in the point we want to analyze the product. I mean, in the farm, in the field, in the industry. So this is a very important characteristic. Also, I would like to introduce you which is the technological context in which we are today. So for this, I'm going to use this slide with the 5 industrial revolutions that we have. As you can see, the first industrial revolution was in the 18th century. In the 19th century, we have the second. In the 20th century, we have the third. And now we are in the 21st century, sorry. At the beginning, we have the fourth and we are just in the transition to the fifth. So it is clear that the acceleration of the changes is much higher today. And the other thing I would like to stress is, which is the difference between the fourth, that we, all of us recognize, and the fifth that is coming, or in some sector is already exist. In the fourth industrial revolution, everything was focused in the digitalization and in the introduction of the artificial intelligence. But when we move now to the new industrial revolution, we understand that we need to combine human or natural intelligence with artificial intelligence to get more profit of this. And also with a perspective of sustainability of the system, and also with looking at the social impact of this combination. This technological context makes me the possibility to introduce you, which is now our current status in the near-infrared sensor. So for me, this new era on NIR, near-infrared sensor, we are also in the transition between a fourth and fifth revolution. From a lot of time, we have recognized that NIR was a very, very powerful analytical tool, and it is. But now, we are, just to have data, to have measurement is not enough for us. We need to provide more, and NIR is very, very suitable for this, because we can provide an intelligent, adaptive, and connected decision support system using this information that is provided by NIR sensor. And how we can face this, how we can address this. For this, we need, of course, advanced sensors. So the improvement in the hardware is very, very important. Also with these advances in the data science, and in this case, artificial intelligence methods are also a key point. But also we need these other 3 points that you can see in the slide. We need to increase the interpretability of the results. We need to increase the connectivity. I mean, with this, we need to connect this signal with other signals in order to extract more information and can provide the support that the industry needs. And finally, we need to provide autonomous decision. This is the thing that the context, the industry is demanding today. I'm going to show you how we have advanced in the hardware, in the development of the sensors. In the case of the NIR sensor, the evolution has been a real revolution. So you can see here, this is the first commercial NIR instrument is from the 60s of the last century. In the USDA, was development in the United States. And now, this is the picture that we have now that is very, very different, as you can see. We have new technologies, we have high portability now, we have small sizes of the device, connectivity, and this provides us opportunities for in situ and online application, and for making real-time decisions. This, I want to say that just a few years ago, some of the application that we are developing today was really unthinkable. So this is in part due to this sensor development. The other important thing is the data science. And of course, in this topic, we have advanced a lot of. And of course, the eruption of the artificial intelligence method is an opportunity for our technology, but also it's very challenging. You have this challenge that you can see in the slide that we have to be aware before to use artificial intelligence without seeing that in some occasion, we are not doing the best use of it. So, which are these challenges that we have when we work with NIR? Low data availability. We have usually, as you can see, a small and fragmented database. I mean, we can have many data with the NIR sensor, but for developing the model, we need also reference data. This is a limitation because usually this is expensive, time-consuming. So when we talk about, I used to hear about the data is very cheap or something like this in many conferences. In our case, it's not very cheap. So we talk about hundreds and thousands of data, but not millions, like in other topics, in other fields. So this is a limitation for the application of artificial intelligence method. The second challenge is the overfitting of the model. Of course, this is linked to the previous one. If we have a limited sample size, the risk of overfitting is higher, but also is linked to the collinearity that we have in the variables that we are managed. So, of course, it's important to know this, to manage this in the better way. And the last thing is the lack of interpretability of when we use deep learning. Sometimes we are losing the link between the spectral features and the chemical meaning. And this is very important for our technology. So it's just to be aware which are the things that we have to especially look for to improve the results. How we can manage this thing that I commented before. The first thing is we can do data augmentation. And this is one of the topics that in our field, many colleagues are working now. But in this case, I have to say that the first approaches that I have seen, in my opinion, are not the best. So we have to work in data augmentation, but respecting the properties of the spectral data. The other thing is the combination of chemometrics and artificial intelligence method, in this case, to gain in the interpretability of the result. And the third one, over the paper is the easiest one, but in the practice is the more difficult, is to share data for building a spectral data space. This has happened in other fields, for example, in medicine, and because of that, you go to an imaging diagnostic and you can have a good result. But in our field, there is still a lot of people that don't like to share the data because the confidentiality is very important, because they are very expensive. So this is also a topic that we have to explore more, but is the most difficult one. And this is for hardware, for the sensor, for the data science, and now to achieve what I presented before, that is to get an autonomous decision support system, we need to advance in the connection between the NIR signal and other information and communication technologies. You have here an scheme that you can see how we combine our spectral data, our model, everything, some of them in cloud computing, other in the edge computer, in order to provide an output for the producer, for the industrial, for the consumer. It depends in which part of the chain you are going to be. You are going to have an information, but the important thing is that you have information of the products that you are working on or that you are going to consume. And to show you how in our group we are trying to manage this integration of NIR and other information and communication technologies in order to provide a decision support system, I'm going to show you two cases of studies. In this case, the first one is related to the quality control and authenticity of olive oils. As you know, olive oil is one of the most important food products in our region, in our country, and we have different qualities. We have 3 qualities: extra virgin, virgin, and lampant. And in our group, we have several projects working on the development of application using NIR sensor for the assessment of this product. In this case, you can see different sensor that can be used in the lab, in the line, but we are very, very focused. I don't know if I can point. Yes?
I don't think so.
No, okay. We are very focused in the development of application with very, very low-cost portable instrument, because the olive oil instrument, we have big companies, but we have a lot of small companies, and for them to get this technology, to make that this technology is affordable for them, it's important to develop this application in this low-cost sensor. And I can say that, it's this one. We have worked first in the development of qualitative application for the assessment in qualitative parameters. You can see here acidity, ester content, waxy content, total polyphenols, but there is a long list that is not possible to put here. I am here comparing 2 instruments. In the first line of each parameter, you can see a lab instrument, and the second one is a very, very low-cost portable instrument. We have very good results for all the parameters, and also we have very similar results when we use a lab instrument and a portable instrument. And this is a very good news for the industry, because of course, to implement this low-cost instrument is easy and is cheapest. Also, in the case of the olive oil, we are also working in the development of application for the prediction of sensory attributes. As you know, the taste and the smell of the olive oil is very important, and usually they are analyzed by a panel test with expert. So we decide to prove if we can predict these characteristics, and we can. You have here the fitness, and we have very, very good results. And the final approach is just to use the spectral signal to classify the sample in the commercial categories, using just the spectral information. It's a discrimination, it's a discrimination model in this case, and we have a percentage of hits over 81% and 95%, depending on the class that we are predicting. The other case of a study that I would like to I'm looking at the time and I say I have to go faster, but no. I'm going to show you which is the final application that we have developed in the case of the olive oil to improve the digital labeling of the product. In this case, all the information that I showed to you before is implemented in the platform that we have designed, and you can read the QR code of each bottle, and with your mobile phone, you can have all the information provided by the sensor. Each olive was analyzed in the origin, and in this case, we have all the information directly in the market for the consumer, for the industrial, whatever we want. The second case of study, now yes, is this, is the use of NIR for process control. NIR is a very, very suitable tool for the process control because we can implement very easy this sensor in the line. I want to show you an example of a feed plant in which we are working in the monitoring of the composition and homogeneity of the product. They have several lines of production, and they have several analysis heads, NIR analysis heads in each production line in order to follow this, the assessment of this composition and homogeneity. You can see here which are the sensors analyzed in the pipeline of each production line. And then in this case, we have combined all the information provided by the NIR sensor with the industrial SCADA of the plant. Why we do this? Because we want to provide the operators in the plant with a real automate response in which they don't need to say, okay, I have to do this or to stop this or to whatever. In this case, what we want is that to provide autonomous decision based on information, based in this case of NIR information. So this is a real project that we are developing with a company in Seville here in Spain. And, and now, to go with the final reflection, just to say that NIR sensor provides a digital fingerprint of the product. In this case, this enables us the opportunity to improve the traceability, the digital labeling of the products, the process control, everything that I mentioned before. The success of this new era of NIR, that I call NIR 5.0, will depend not only on better algorithms and sensors, but also on robust data ecosystem and, of course, on strong collaborative networks. I would like to say that the new era is about transforming spectral data into intelligent knowledge. This is our focus today. And the last thing, but not less important, is the training. I work as a full professor in the Faculty of Agriculture and Forestry Engineering in the University of Córdoba, and training is very important for us. In this case, I would like to say that the training is essential to train the new generation of experts that they are going to deploy these emerging technologies. Is essential to advance. So always I would like to stress this, because sometimes we think that artificial intelligence could do everything, but this is not. We have to combine, we cannot forget that we have to combine our intelligence with the artificial intelligence. This is just to show you my research team in the University of Córdoba, and this is all from my side, and thank you very much for your attention.
Okay. Thank you, Lola, for your fascinating presentation. Now it's time for our second speaker. He's Dr. Abdo Hassoun, with a PhD in Engineering of Biological Functions. He's a researcher at the intersection of food science, innovation, and sustainability, with expertise in food analysis, quality, and measurement. He holds a bachelor's degree in agricultural engineering from the University of Aleppo, Syria, and a master's degree in food science for Blaise Pascal University in France. Following his PhD, he completed a postdoctoral position at Nofima, in Norway, and he is the founder of SAFIR, Sustainable Agri-Food Tech Innovation and Research, a non-profit organization dedicated to advancing sustainable agri-food innovation, and he is also affiliated with the University of Aleppo, Syria. His work focuses on Industry 4.0 applications in food systems and sustainability.
Gracias. No, I will not take this presentation in Spanish. This is the only word I know. So, yes, we will be waiting for the presentation. It's stressful. I'm stressed, nervous about this, because the highest number of people I am used to be in front of is 5 people. And these are my wife and 4 children. So, okay. I will be talking about Industry 4.0, use of Industry 4.0 to support a sustainable food system, especially through reducing food loss and waste. The structure of my presentation. So I will start by giving a general overview of challenges facing food systems, especially food loss and waste. Then I will introduce the concept of Industry 4.0 and give some examples about using Industry 4.0 technologies to reduce food waste and loss. Finally, I will end this presentation with some key takeaways and a short perspective for the future. So just an important point before to start, what do you to expect in this presentation? Because since yesterday, we have seen very interesting presentations with many examples about use of artificial intelligence and other Industry 4.0 technologies in the agri-food sector. But today, I will take one step back and give a general overview of all of these technologies used in the food sector, especially focusing on food loss and waste. So food systems are under pressures from mainly three kinds of challenges. Environmental stressors, you know, climate change, water scarcity, biodiversity loss. Also geopolitical and economic disruptions, like conflicts, like the ongoing one in Iran, for example, and its huge consequences on blockchain in the food chain shocks. And also there is a lot of issues related to nutrition and our food insecurity, like hunger, malnutrition, and especially food loss and waste. So food loss and waste is one of the most urgent challenges facing our food system. So we are all familiar with these numbers and figures. So I will not go into details, but I would like to highlight a fact that when food is wasted, that means that all resources behind it are also wasted. So land, water, energy, money, human effort. That's why by reducing food loss and waste, then we can improve environmental performance. We can reduce economic cost, and we can also strengthen food security and social sustainability. It's important, I think, to distinguish between food loss and food waste, because food loss occurs earlier in the food supply chain during production, harvesting, storage, processing, and distribution because of logistics inefficiency, like weak infrastructure, poor storage, while food loss occurs later at the retailer and consumer levels because of over-purchasing, for example, or cosmetic standards, or consumer behavior in general. Lula has already mentioned this, so I will not spend much time on this, but I will be focusing on Industry 4.0, and for those who are not familiar with the term, Industry 4.0 refers to the fourth industrial revolution. So we have technologies like artificial intelligence, big data, smart sensors, digital twins. All of these are working together now in order to improve flexibility, profitability, and decision-making. Industry 4.0 is often seen as a convergence between three broad areas or domains: digital, physical, and biological sciences. So the real power of Industry 4.0 doesn't come from one technology applied alone, but from multiple technologies applied together. So we can have, for example, a robot, but if it's not connected to sensors, smart sensors, artificial intelligence, data, so it will be, sorry for the term, stupid robot. So it can move, but it cannot sense or adapt or make decision. So this is the amazing thing with Industry 4.0, that it connects machines with sensors, with data, with intelligence, all of one smart system. In this slide, I present 8 of the main Industry 4.0 technologies. So these are the main technologies used in the food sector, in agriculture and the food industry. But it's important to mention that this is not a fixed list of technologies. So it depends really on the sector and applied field. So even in the food sector, you may find other technologies could be relevant also, like, so what is not mentioned here, like extended reality, for example, big data, or connectivity, advanced connectivity, 5G, etc. So the idea is not to see these technologies like a fixed list, but rather like evolving and dynamic ecosystems of technologies. So I would like to introduce now the concept of food Industry 4.0. So it's the application of Industry 4.0 technologies in the food sector, in agriculture and the food industry. So over the last few years, we have published many works related to this topic. For example, this is one of the books published with SAFIR 2 years ago. So we have introduced good concepts, I think, food quality 4.0, food safety 4.0, food traceability 4.0 is in this book. And now we are expanding these chapters into each one into full books. So after the success of that first book, now we are building a full book series related to this topic. So we will try to develop a volume or a book for each food category. So we have already published in the context of this book series, the one about food, seafood 4.0. And we have 4 other books under preparations: dairy 4.0, meat 4.0, olive 4.0, and we have a honey 4.0. So if you are interested in this topic, you could, of course, please feel free to submit your idea, like a book proposal, to our book series. In the literature, you will find many related concepts or terminology related to this, to Industry 4.0. So this terminology may vary, but the core idea is the same, which is applying Industry 4.0 and technologies and principles in agriculture. So you will find, for example, agriculture 4.0, which is the agricultural equivalent of Industry 4.0. You have also, you can see precision agriculture. So it's about applying inputs like fertilizers, irrigations, etc., accurately and precisely where needed, when needed. You could have also, you could see smart agriculture. It put more focus on real-time monitoring and automation. And we have digital agriculture. So it's like a broader term about integration of digital technologies like artificial intelligence, big data, other technologies across farming systems. Now the discussion has expanded toward Industry 5.0. So Industry 4.0, the focus is on automation, digitalization, profitability. Now, Industry 5.0 added more emphasis on human centricity, resilience, and sustainability. So in the food system, technology will not only, or this is a promise of Industry 5.0, not to only optimize operations, but also to support people, to strengthen resilience to shocks, and to contribute to broader societal and environmental goals. There is a lot of debate in the literature about Industry 5.0. So is it like real revolution or simple evolution of 4.0? Personally, I think that it is somewhere in between. So it's not a full revolution because we don't see like a sudden technological break or fundamental change. But also it's not a simple evolution because we are seeing huge progress from robotic, for example, toward cobotics, from 3D printing toward 4D printing and behind, from Internet of Things toward Internet of Everything. So for me, it's 5.0, it's an important step behind 4.0. And this is what I argue in this book. This is my first authored book, and it will be released soon. I hope you will find it interesting. This is another, now we will move to the third topic, which is to explore how Industry 4.0 technologies could help in reducing food loss and waste. We examined this recently in this book in the broader context of food sustainability. So this book also published last year with Springer Nature. It investigates how Industry 4.0 can contribute to sustainability in its three main pillars, social, economic, and environmental pillars. So food Industry 4.0 doesn't only help to reduce food loss and waste, but also can help to progress towards many sustainable goals like the SDG 1, no poverty, SDG 2, food security 3, etc. Now, I would like to highlight one of our ongoing projects. It's called PASPAC 4.0. So we are trying to valorize waste from the Mediterranean countries, so especially pomegranate and date, and using some Industry 4.0 technologies like blockchain, 3D printing, artificial intelligence in order to produce biofilm in the context of intelligent and active packaging. So this is one example on how to reduce food loss and waste. So in this way, we can reduce food loss and waste, but also decrease the use of plastics, which is excessively used in packaging, and ultimately contribute to sustainability. Now I will give a short overview of each of these Industry 4.0 enabling technology and how it could contribute to reducing food loss and waste. And we'll start with artificial intelligence. I'm not expert in artificial intelligence, but I'm curious about this speed and very strong development. You see here, I looked at Scopus, a publication index in Scopus, and you see the number has increased from only 3 publications in 2013 to more than 600 publications last year. So all these publications are about use of Industry 4.0 in the context of food loss and food waste. So it's really huge interest from, at least from academic point of view, on use artificial intelligence in this context. So how can artificial intelligence contribute to reducing food loss and waste? So I have here 4 examples, but you can find in the literature many other examples. So for example, by reducing, forecasting demand, we can avoid overproduction. Another example could be like optimizing inventory management and very well estimating shelf life. Then we can prevent avoidable loss and loss in retails and during storage. Other applications related to sorting and grading of food inspection. You will find many other examples. A lot of publications also about personalized nutrition and recommendation for consumers. So I will not go into details because my objective today is to give a general overview of all of these technologies. Another technology is 3D printing or additive manufacturing. So this technology, unlike conventional manufacturing that remove materials in order to make products, and finally these materials would generate a lot of waste. So additive manufacturing produce food by adding one layer by layer. So in this way, it will reduce food loss and waste significantly. And this technique, you will find it applied in many fields like personalized food or novel food products or also food packaging. Food chain is complex and become more and more complex, and this complexity requires more than traditional paper-based documentations and manual records. That's why recently there is a huge interest in developing digital technologies like blockchain. So recently we introduced the concept of food traceability 4.0, and blockchain was one of the main technologies in this framework. So in applying this technology with other Industry 4.0 technology like big data, artificial intelligence, and Internet of Things, so we can have like more reliable and secure data sharing and more control on food quality and safety in general. The potential of blockchain could be even greater when combined with the Internet of Things, which are like device and sensors interconnected and communicate and exchange data via internet. So this is an example on how Internet of Things could be used for freshness parameters like temperature, quality, etc., and then adjust prices earlier in order to have more food sold and then less waste by the end. Smart sensors. We have many types of sensors, like optical sensors, like spectroscopic sensors, but many other types, like chemical sensors, biosensors, etc., to be considered like smart. So sensors should have these characteristics, as you said, also being small, low energy consumption, etc. So I will move to almost the last. Here we have, I present 2 examples from my previous work at Nofima on how to use spectroscopic techniques in enzymatic hydrolysis and inspection of problems in or default or in fish, for example, in salmon. So this is my area of expertise. I have expertise here, especially. So if you have questions, please only ask me from this slide. We will have maybe a discussion later during the question session. Another technology is cobotics. And this is like a simple comparison between robotics and cobotics. So robotics is rather Industry 4.0, while cobotics or collaborative robotics, it's more aligned with the vision of Industry 5.0 and how it's used to reduce food loss and waste. Maybe we will discuss this. Also, later I will go faster because I see that I'm out of the time. So we have digital twins also that could be used to reduce food loss and waste. So let me get directly to the takeaways. Sorry, there is a typo here. So the main message of this presentation is that food loss and waste is still a huge problem, and we still need to look to innovative solutions. Industry 4.0 technologies could have potential, especially when used combined with, if we can use many technologies together, like artificial intelligence with sensors, with robotics, etc. But still, we have many challenges that we could discuss later also. And since yesterday, we have heard about adoption and challenges facing adoption. But to overcome these challenges, I think generally we still need more research, more development, and multidisciplinary collaboration. For the future, the direction is clear. I think it's toward Industry 5.0, where digital innovations are more strongly related to human needs and to sustainability. Thank you for your attention.
Thank you, Abdo, for your interesting presentation.
No problem.
This is my phone.
Okay.
Lola,
Thank
this
you.
is mine.
Ah, this is yours. Oh, sorry.
We will now open the discussion, but before opening the floor, I know that you have both mentioned in your presentation, but I'd like you to tell a little more about what are the main differences between Industry 4.0 or 5.0. In your case, Lola, if you want to talk a little more about the differences between NIR 4.0 and 5.0, and in your opinion, what challenges still limit the implementation of the solution that you have presented? So,
okay, I can start. Well, as I mentioned in the presentation, the transition between the fourth and fifth industrial revolution, in my opinion, is this. In the fourth, we are focused just in the data, in the digitalization, in artificial intelligence. We thought that everything could be done by others, in this case, the artificial intelligence. And in this transition, we realized that we need to combine our intelligence, the natural intelligence, with this artificial intelligence. And in the same way, in the NIR sensor, we are in this point because, of course, we have focused a lot in the development of the sensor, in advancing in data science. But now, as we need to involve more things, for example, the interpretability is very, very important to get this final autonomous decision that we are looking for. So this interpretability needs our expertise. It's just not to say, okay, we can do everything in a robotic way. No, this is not possible anymore. So we have to invest more in combine what we can put from our side, from our expertise, and what we can have from, of course, this advanced data science, this new development of sensor. So I think this is, in my opinion, the challenge that we have today in the case of my field. And to answer to the second question, which are the limitations to adopt this technology? I have to say that nowadays the technology is well recognized by the industry, by the scientific field, but of course we need, as I mentioned, we need a lot of data for development the models. This is, of course, a limitation, is in particular when we talk about agri-food products or biological application. When we talk about chemical application or other, this is easy because everything is more homogeneous. We have less sources of variation, but in our case, we have a lot of sources of variation, and we have to include this variability in order to get robust model, and this is, of course, a challenge. So this is, because of that, I talk about data augmentation and this thing, and to share data, but this is our challenges for the near future.
Okay.
Yes. From what I see in the literature, in the scientific literature, Industry 4.0 is more based on these three pillars: digital, physical, and biological sciences. But in the future, in Industry 5.0, I think more fields should be included, like social sciences maybe, because in 5.0 there is more focus on a human. That's why you have technologies like cobotics, collaborative robotics instead of robotics. So in terms of framework, we have these differences, but also in terms of technologies, as I mentioned, so in 4.0 you will have cobotics, 5.0 it's rather called cobotics. So you have 3D printing, but now you have 4D printing and behind in 5.0. You have Internet of Things in 4.0, but in 5.0 you have Internet of Everything. And even the progress in artificial intelligence has been really huge and has transformed many fields, including the food sector. So instead of traditional or weak artificial intelligence, you have now advanced form like generative artificial intelligence, etc. But still, I think there are a lot of confusion in the literature. That's why I wanted today to talk about these concepts, because I come across a publication recently in a very prestigious journal. I think most of you, maybe you know this journal, Trends in Food Science and Technology. And in the title, you see 5.0. But when you look into the content, there is nothing from 5.0. I don't know why it was 5.0 in the title, while it's like basic Industry 4.0 in the content of this article. So this is an example to show that there is still a lot of confusion in the literature, and many now even talk about 6.0 in order to have like more publications. So, but we should be reasonable. I think we should be focusing in 4.0 now, and maybe like for a vision for the future, we can deal a bit with the 5.0.
Okay, thank you. I totally agree with both. And what have you said before, the need for training, the new generation of people that have used and implement these technologies. So it's time for question. Is there any question here?
Thank you. Great talk. I have a question for Professor Lola. This is Daniel from the National Center for Food Tech Technology. You were mentioning that you were using a near-infrared spectroscopy to address and to predict sensorial features of olive oil, for example, which is actually now in the food industry very important to use these type of sensors in order to reduce the inherent variability of the tasting panels. Now we are moving more towards more complex sensors like electronic noses, electronic tongues, and so on. So I'm wondering, what are the advantages of using near-infrared spectroscopy compared to this? And also, have you done any statistics to compare the performance of the near-infrared against tasting panels? Like, do they improve it? Is it comparable? Can they substitute them? And also, another question, if you actually try to predict any other feature more than fruitiness or in any other matrix?
Okay, thank you very much for the question. Well, in the case of the olive oil, we have trained the models with all the information provided by the panel, sweetness, bitter, pungency, but to put here in the slide, I just decided to put one of them because the limitation of the time. You say that the electronic nose or electronic tongue is more complex, but I have to say that no, NIR provides a more complex signal, provides more information than the other. We have not compared, because we don't work with electronic nose or with electronic tongue, but I have seen in the literature which are the performance of other sensors. And I have to say that we are very happy with the results, taking into account that, of course, sensorial analysis is related, of course, with the composition of the product, that is a bit more. So with the information and with the result that we have now, we can say that the performance is quite good or very good. Taking into account that this is a very, very complex application. But the thing about, because you asked me that if I don't remember the last.
Maybe like
In
if
other
you have
matrix.
done any external test.
Okay, if I can substitute, okay,
Yeah.
yes, no. The idea is not to substitute, it's to complement always, because always we have some sample that with the model, with the prediction model, always we are going to have sample that for us has some uncertainty. So in this case, we can use the panel test, and also we have to recalibrate the model, because as this kind of products have a high variability, we need to recalibrate to cover the new variability that we are going to have in the future years. So the idea is not to substitute the panel test, is to complement and to provide more information of the sample and to inspect more amount of sample. Because now a limitation is the cost of the panel test, of course, the regulations say that they cannot test more than a number of samples per day. They have a lot of regulations, so the idea is to do in an automated way this evaluation, but not the substitution of the panel test. I want to say, because if not, this is a very, very problematic. So,
Yes.
But with the result, now we have a very good performance, but I have to say that this is still a provisional result. Okay.
Very interesting. Thank you.
We have here other question.
Thank you. I had a question for Dr. Lola related to the integration of AI into near sensors. Is this already happening at, let's say, commercial level, or is it something that it's still in, let's say, innovation cycling?
Okay. It's already happened, because there is a lot of colleagues are scientific level, but also commercial solutions that are integrating deep learning in processing NIR data. But as I mentioned, it's still a challenge because sometimes I have to say that I have seen some of the approaches working with artificial intelligence in this data. In my opinion, sometimes this is, I have to say that it's like, okay, I'm doing this because this is on fashion, but really we are not covering the what we expect to have when we work with NIR and to get a robust model. Because in my opinion, the important thing is to have a robust model to can predict data. And our objective is not just to publish a paper. That could be in somewhere a focus or some college, but is to give solution to the industry. And in this case, even when the deep learning is in use, we have something that are not working well. So. It's an innovation we are already used, but also it's an innovation because we have to fit well these new technologies in our technology.
May I added something? From my experience in my previous work at Nofima in Norway, this is really a very hot topic, and in use there are a lot of devices based on near-infrared spectroscopy that are being developed and used in practical in industry. For example, in seafood, we can use especially portable devices based on spectroscopy to measure fat content, for example, or protein content in fish. Many other parameters could be measured. Even in cooked fish, you can use devices based on spectroscopy to measure inner temperature inside fish. So, I mean, it's really many devices are in use now.
Just a thing. There is many application in the food industry, but what I want to separate is the application working with the traditional processing methods and the application using now deep learning.
Deep learning and online monitoring.
Yes, but still, yes, there are many approaches, but still we have some problem in this because the limitation of the data size of the
yes, this is one of the main challenges, because you asked about challenges, right?
Yes.
And may I added also here that one of the main challenges is, as Frank mentioned yesterday, so I would like to highlight this point, is the need to robust ethics, in fact, in general, because there are a lot of challenges, of course, related to cost, infrastructure also, but I think more importantly is ethics and accountability. So because now, unfortunately, you know, technology is used somewhere to harm people, not to be useful, but even to kill people. Artificial intelligence, for example, and algorithms, you know, is used in Gaza, for example, people. So this is really sad. So we need really strong accountability and robust ethics to monitor all of these new technologies.
Okay. We have no time for more questions. We thank you very much, all of you. And if you have more questions, you can ask them in the coffee break. Okay. So thank you very much.
Thank you very much.
Thank you.
Lola.
Okay. Okay.